Claude Code sends 33,000 tokens to Anthropic before it reads a single word you type. OpenCode sends about 7,000. Same task, same model, same machine. A firm called Systima spliced a logging proxy between each harness and the model API and measured exactly where every token goes. Published July 12th. Here's what they found and why it matters to your workflow and your bill. If you use Claude Code every day, this is not an abstract benchmark. It is where your context window disappears and where your usage meter is actually climbing. A 33,000 token floor eats close to a sixth of a 200,000 token window before you have written a single line of a prompt. And prompt caching, the thing that is supposed to make repeated overhead cheap, behaves very differently for these two tools. Here is the breakdown. Systema asked both harnesses to reply with exactly one word. Okay, Claude Code's first request carried a 27,344 character system prompt, 27 tools defined in 99,178 characters of schema, and almost 8,000 characters of injected reminder blocks before your prompt even arrived. Total, about 32,800 tokens. OpenCode's request, one system block, 10 tools, about 6,900 tokens. Tool schemas are the dominant cost for both. Claude Code ships an entire background agent and orchestration suite by default: cron jobs, monitoring, worktree management, push notifications, a full delegation catalog. OpenCode ships 10 classic coding tools and nothing else. Swap the model and the gap moves. On Claude Fable 5, Claude Code trims its own system prompt from 27,787 characters down to 10,526. The gap narrows from 4.7x to about 3.3x. Same harness, same tool count, a smaller instruction set for the newer model. Then there is cache behavior, and this is the part that actually explains a climbing usage dashboard. OpenCode's request prefix was byte identical across every run Systema captured. It pays to cache its payload once per session and reads it back at a tenth of the price for the rest of the conversation. Claude Code rewrote its cache prefix mid-session, run after run. On one match task, it wrote 53,939 cache tokens against OpenCode's 1,003. That is a complete rewrite of a 43,000 token prefix in the middle of a single conversation, billed at cache write rates for content that had not changed. Two more multipliers, and one of them is a trap worth checking right now. A 72 kilobyte instruction file adds about 20,000 tokens to every single request for both harnesses. Symmetrical, no surprise there, but Claude Code only reads a file named claude.md. It silently ignored the identical file when Systema named it agents.md. OpenCode reads either name. If your team standardized on agents.md for cross-tool compatibility, Claude Code may not be reading your instructions at all, and nothing will tell you that. Sub-agents are the biggest multiplier they measured. Fan a task out to 2 sub-agents, and the same 121,000 token job jumped to 513,000. That is 4.2x because every sub-agent pays its own bootstrap cost, and the parent then re-ingests the whole transcript. Here is the counterintuitive part. On a multi-step, write, run, test, fix task, the gap closed almost completely, and on one run, Claude Code's total came out lower. Why? Claude Code batches multiple tool calls into a single round trip. OpenCode calls one tool per turn and repays its smaller 7,000 token baseline every single time. A big baseline paid 3 times can land in the same place as a small baseline paid 9 times. And in a real production configuration, MCP servers, plugins, and a real instruction file, not a clean lab setup, Systema's heavily configured OpenCode setup actually metered higher than Claude Code's, about 90,000 tokens against roughly 75,000. Config, not the harness, ends up setting the bill. So what do you actually do with this? Check which instruction file name your harness honors. claude.md versus agents.md is not cosmetic. It is the difference between your rules being read and being silently skipped. Watch sub-agent fan out specifically. It is the single largest multiplier in this entire study at over 4 times the direct task cost for 2 subagents. And do not assume the harness with the smaller baseline wins your actual session. Count your requests, not just your floor, because a serialized small baseline tool can outcost a batching large baseline 1 by the time real work gets done. The full methodology and every number is linked in the description if you want to reproduce it yourself. The rig is about 200 lines of a logging proxy. Try 11 Labs, the AI voice in this video, https try.11labs.io RDSBYJPTTTO. This video contains affiliate links.